Rock's offices today. Actually, I've got Mr. Bill Drakeley here with me. This is our next segment of our Ask the Masters deep dive. We've actually collaborated together on a project that the Drakeley Pool Company worked on, this one is in Connecticut.
Greenwich, Connecticut.
Had some acrylic panels on it, had 10 or 15 different details on the edges, and some good complications. So we're going to break this one down, kind of the design side. Bill brought us in just to help with some of the ancillary details of the acrylic panels. And then kind of work together on modeling the shell so we can figure out some of the edge details. But so without further ado, this is Rick Chafee with Ask the Masters, and we're into a deep dive. At the end of the show, we'll go through and you'll have our contact information and numbers. You can see in this background image kind of the overall project. We're right on the water in the ocean where the project's at. So they got coastal issues to deal with. We've got some really cool features. We've got an in-floor floating pool cover that comes out and some really complicated edge details. So part of the overall process of doing a pool like this, the planning stage is probably the most critical. And even though we work together with Bill to plan multiple pieces of this, there's also another big piece of this team out there with the architect, the landscape architect, the owner. So we had to propose multiple different solutions and work through multiple problems with him to get to the final end result the client wanted, as well as the landscape architects and the architects. So we are not necessarily the creative designers on this at all. We just worked in conjunction with Bill Drakeley and his team, putting together all the parts that we needed to get a project like this to come together. So,
well, we are by default. We had to be creative at some of the solutions.
Oh yeah, absolutely. So, and you know, some of the design considerations we'll talk about today in this presentation is going to be the use of acrylic panels and using them on a negative edge, how those edge details have to work together. And critical to that is the fact that we've got different thermal properties between concrete and steel and acrylic. Some of the different perimeter overflow details and how they all are going to tie together. Some of the structural issues with that, and then also we're going to cover a little bit of the in-ground floating cover system that we saw installed on this one that's also got a safety edge. We'll also go through some construction topics in general. So, you know, general best practices, you'll see a lot of that being done in the images. You'll probably see some bad practices too. We'll talk about them. We did some well, it's the Drakeley pool. It's got to have some bad practices, right? It's a multi-day shoot as well.
We're not going to cover any of that crap.
So it's a multi-day shoot. So he shot this pool and cast some of this pool for 3.5 days. We got some subterranean equipment location underneath part of the deck in the pool, acrylic panels, obviously, the infamous stainless corner mullion we had to put in this acrylic panel on the fly, some perimeter overflow tricks we played with, cold weather construction techniques because we were in freezing climates, the underground pool cover, and then some winterizing concerns of acrylic panels, perimeter overflow pools, glass tile, that kind of stuff. Just another overall image. You can see we've got an all glass perimeter overflow spa. Bill, you want to walk through any of this image and kind of talk about all the different details we're looking at?
Yeah, so we start at the top of the pool, bluestone deck with the glass fencing around it. It's a standing ledge, 6 inches of water, and we had these original landscape architect wanted these floating steps, and the floating steps are not floating, as you can see. They have water over the top. So when we first met with the owner, we first met with the architect and landscape architect in a meeting. Landscape architects Wesley Stout Associates out of New Canaan, bright guys, and they designed some of this. We worked with the architect and the builder for the house. Owner's rep, the owner, his wife, and everybody met at the office. And they says, okay, Bill, what's, you know, we know you do high-end work. What's cool for the pool industry? I said, well, there's perimeter overflow, there's vanishing edge, there's glass tile, there's gutter systems, you know, raised spas. I said, there's acrylic panels where you can go underwater and look through and see through from upper deck locations out into the ocean. I said, there's a lot of things. I said, there's even covers that come out of the floor. I said, you know, so there's we can do a lot of things for a pool project that maybe some people can't do, but you know, we're comfortable with, you know, doing a lot of that stuff. And the owner says, okay, let's do it all.
Yeah.
I says,
open your big mouth and see what you get.
I says, what? He says, yeah, do it all. Do all that stuff. I says, who, me? So that's what we did. So back to my point on the shallow end rig. The architect drew floating steps. Well, we have a grand oak cover below that seating area, which is not going to work with a floating step, clearly.
Right.
So that's why they're just under the water, enough to have the flotation of the grando cover go across it. So you're looking at covers in the shallow end. You can see the notch outs, vanishing edge into a trough on the long wall side ocean, and vanishing edge acrylic on the corner down below, and then the house side where the grass and the kind of the patterned big stone decking is. We fabricate our own stainless steel to be bolted to a hidden gutter below that inverted edge. You notice the edges are opposite on either side based on what we have to do. So we got perimeter overflow on one side against the deck, and here perimeter overflow around the spa, which spills into the pool, and then vanishing edge away from the pool on the ocean side, tying into the acrylic panels or that corner, and then glass tile around some of the, we featured glass tile around some of the features and some of the elevations.
Yeah, I think one of the hardest things we did on the design side, and we'll show a video of some of the renderings we created, is we've got, with all these different edges, it seems simple on paper when you start drawing them in plan view, but as soon as you start modeling a Lautner edge that ties into a negative edge, and then you have a concrete negative edge that ties into an acrylic negative edge of a narrower thickness, you start affecting the actual line of the water and how it might look from the house and getting them all to work together. So that was, one of our, we probably spent more time with those concepts to work through how to get those to keep going the way we want to. So same picture of the pool, just the other direction. Now you can kind of get a better feel for the elevation changes, the drop off. Very good visual of the acrylic panel. You can see how the acrylic panel is narrower dramatically than the shell of the pool. Part of that's to get structural rebate to hold the pool, but obviously the concrete structure has to be thicker just for construction and steel coverage. And then we had to create all ways to transition that negative edge as it gets back towards the concrete deck. We had to transition and hide how that changes as it turns the corner. So we played with a lot of different details. We'll show some of them as we go through.
That runnel or that narrow trough along the long wall steps down as the patio and the grass and the upper terrace goes down to the lower grass. So it all steps down, has little waterfalls, and we have LED lights in there as well.
And then under this section here of grass, the middle section of grass is actually the equipment room. So we got subterranean equipment adjacent and below the pool. So kind of cool, very unique. This gives you a little bit, just a simple plan view of what this pool is. Although it's a, simple rectangle with nothing major going on, it's probably got 15 very complicated problems to manage and make all work. So, and we'll kind of break into those and go through it so we can kind of see how that worked and what you got to deal with. So general cross sections, these were early cross sections, and we did end up changing like the angle of the acrylic panel and how the rebate works and how it tied to the floor, etc. But just to give you guys a general view of how the pool works, we did a cross section through the spa, so you can see the lower edge basin, the acrylic panel walls, and the spa and overflow sections. Gutter details aren't even that accurate compared to what we finally built, but it is an accurate general cross section for elevations.
Accurate enough.
And then this is our plan view, so we can kind of see the plan of the pool overall. So you can actually now see where the grando cover sits down below the main floor. If nobody's installed or seen those, it's a slatted floating cover system. Works really well with just about any shape of pool, as long as you can put it in the widest portion of the pool. You can come up and close off just about any type of pool, and even in this one with a negative edge and a flooded coping, we're able to use that same cover and technically be able to walk on it. You'll get wet walking on it because it will sink a bit, but it will protect you, and it helps for winterization, keeping the water warm. On this pool, it being in Connecticut and being on the water and being in the snow, one of the requirements for the client, because he wanted an acrylic panel and glass tile and all those things, was this pool does not get winterized and shut down. He runs it 24-hour or 365 days a year at enough temperature that we don't have any freezing concerns to protect.
He didn't have a choice.
Yeah.
Because the first thing I said to him, he said, "We're going to do all this." I said, "Okay, so I'm going to tell you when I don't know something, and I don't know how this is going to winter. I don't know if it's going to move. I don't know what the deflection is going to be. I don't know how it's going to react." So we'll get into some of the plumbing, but the acrylic panels from the floor going up and the grando cover box not only are their own entity as far as what their manufacturer did and what what their design and aesthetics and covering, but there's a suction in the bottom of the cover box, and there's returns on the on the in front of the acrylic panel in the deep end for the winterization hydraulic loop only.
Yep.
And that runs, and that keeps, we're trying to keep the shock away from it. I mean, water's coming off Long Island Sound, it's staying cold down there. So we're going to keep, we might monitor that water at 53 degrees, or a service company does, we don't. But that's the whole idea, to keep the caulk in the same spot, keep the window in the same spot, not have it move. But I told the owner, I said, I don't know how this is going to, you have to be on board with me to say, this is what we're going to do. This is the smart thing. And I think this is the right thing to do.
Right.
But I don't know how it's going to weather. And you have to be okay with it. Otherwise, I'm not going to put it in.
Right.
And again, to the owner's credit, he was, I appreciate being on the team.
And obviously we took extra precautions and extra circulation loops and all those things so we could maintain this pool throughout the winter at a minimum operating cost, but keep it temperature controlled well enough to work. So this is just another good cross section to give you guys a rough idea where the equipment room sits and how it tucks underneath the trough of the pool a little bit and gets into the shell of the pool. I just wanted you to see kind of what that looks like under the lawn. So this is one of the things we did for this project. This is put together a bunch of different exhibits like this to start looking at all the edge details and then how those edge details would affect as they get to corners and as they tie into the spa and as they hit the acrylic. And so if you look at the upper middle, the initial pool design had the negative edge sloped inward, which is done often, but what that would do, because we have a narrower acrylic panel, is the water line would jut in at some point. And so we started really playing with all the different effects on how we can make those tie together and where we might need to have a column or some sort of transition piece. So one of the design processes we went through and worked with the architects and the Drakeley Pool Company was to come up with whether we were doing a Lautner edge, a flooded coping, or reverse flooded coping, and how that affected us. So this is just an exhibit sheet of that. This is actually a rendered video we put together to take into effect so they could see. If you see the original design, you see how the water line has to step in to hit the acrylic panel in the corner. So it was going to be offset, especially from the viewer by the house. And so we wanted to show them at least, creatively what that looks like, and then went and played with multiple different options. So the first thing to talk about was, since we'd have an offset, let's make it look purposeful. So we offset it more directly, make it a little bit easier to construct, and we could keep the edge the way we wanted. So that was one of the options we just gave to the client to review. And then we gave them, an offset panel. We actually originally didn't have a mullion on this acrylic panel. We're going to talk about that in a minute, and why and how that changed in the middle of the process. So after design, we did have to come back in and put a mullion in the corner of this acrylic glass window because of its thickness and because of some other very recent failures that have been happening in the industry. And so, we ended up going through all these iterations to come up with the best solution and give the client enough time to see what those solutions might look like.
If you take a look at the plan view of the pool, you don't have to flip to this, but there's no room. Intercoastal wetlands, or not wetlands, but the intercoastal jurisdiction, that's our building envelope for the water. We couldn't get any farther than the trough to the ocean. They couldn't get any farther than where that wall is and where the steps are, because that's their setback line, that's their build line. So my pool structure is to the inch on that line.
Okay.
If we moved any farther, take it out.
Okay. So obviously, and in the coastal areas, they're anal and critical about how there's no room for errors at all.
They're all communists.
And of course, the client wants 100% of every inch you can have. So
they're all.
So one of the things, this is just a quick SK sketch to bring it up. So when we were designing this pool, the use of fused panels in swimming pools was still being done on a pretty regular basis, and it's still done today. It's not that you can't do it. But what was starting to happen is the acrylic industry was noticing that thicker panels that were thicker than 4 or 5 inches that were fused would start to fail. The fused corner would start to fail, and we'd start seeing fractures and fissures in the corner. They didn't always fail structurally, but they visually started to look like they're failing. So that's usually more problematic than the actual failure. And so after we had shot the pool, cast the pool, and had our rebates for these panels to be set into, we were then challenged with the task that we had to come up with a solution to put a mullion into that existing rebate without starting construction over. and manage it using the same panel sizes we had already pre-ordered. And so it was quite it was a problem for us, problem for Bill, problem for the client. Changed the look of the pool dramatically. It's not the prettiest part of the pool for sure. We'll show you more close up of it. But the moral of the story is, generally, in general terms, currently, if you're using a panel thickness more than 3.5 inches on a swimming pool, and that's in this condition we were for sure, there's many manufacturers and installers that will no longer fuse the corner. And so you have to be prepared and plan for that. And the main reason, whenever we deal with acrylic, we got to be very careful in the fact that acrylic panels are, their thermal properties are significantly different than the concrete properties are. And so in temperature changes, they do two different things. They grow, they also yield more. So as they get hot, and in a pool like this that might be kept at 90 degrees, it's going to be more flexible and more yielding, meaning it's going to lean and move more. But as well in the winter, the outside of that panel, it could get, down into the mid -10s, right? And the inside of this panel can be 50 or 60 degrees. And so we have a major temperature change from one side of the panel to the other. And as the panel gets thicker, they're starting to have lots of problems with those panels wanting to fail. And so unfortunately on this job, we had to come in and design and mullion kind of overnight, redesign it 16 different ways to make it fit in the space and make the pool structure take it. So
we got stuck. We didn't hear the manufacturer was going to stop doing this until after the fact.
Right.
So I had a schedule to keep, and the owner says, "Where's the panel?" I says, "I don't know."
Yep.
And that was the problem. But
yeah, we were kept in the dark for a long time. We weren't getting updates on why the panels weren't shipping, and basically it was because they were trying to determine if they would still fuse a panel for us. We got short-term final notice, then had to jump to our ass because we had a schedule to meet and weather to deal with and everything else. So
I mean, it happens, but the solution and the fact that I think the thing that we did right was tell the owner, we're on the same team, we're figuring this out, and this is the first of its kind here in the Northeast. So, there's a little leeway. So as long as we brought him in and say, okay, this is what we're doing, what do you think? And this guy was in manufacturing stuff. He was a smart guy. And that really helped us as far as continue the project, continue the communication, and not have all of a sudden pointing fingers. We want to get the job done.
So anybody that hasn't seen Grando covers, or there's a couple different companies that make this. This one happens to be a Grando. We actually have covers that can come out of the floor. So we've got a recessed trough in the construction of the pool with a hydraulic lid system on it. Slowly but surely that floating cover, and you can see this one's an odd shape as it comes out. This is not our pool. This is just a rendering video of how that cover system kind of works to give you guys a feel for what it does. Lots of pieces and parts that need to be dealt with in this kind of situation is dealing with the size of the vault, the location of the vault. There's a hydraulic motor that has to turn the cover up and down. The cover actually floats on its own accord, and then the door operates to open up. So major safety concerns, but major structural and construction concerns because of all the tolerances we need to maintain to make things work.
Tolerances were critical. They're a ½ inch. The box is about a ½ inch or so, less than a ½ inch square in order for this to work. The other thing is we learned and found out is our cover is up against that shelf, that shallow, and you can't put a return on the vertical part of it. Otherwise, it pushes against the lid coming up.
Right.
So we were going to put ozone returns in there for sanitation and stuff, and we had to change that because of the cover and the cover lid. They'd be fighting each other.
Yep. So yeah, when you get involved in this kind of system, you really definitely want to work with the manufacturers and understand those things, because as this cover comes up, it has to float and kind of flip in the right direction. They work excellent, but if this pool was even an inch out of square from one end to the other, this thing could get bound up and not work inside the pool. So yeah, tolerance has become extremely critical. But the end result is a really slick cover system. They're very flexible in shapes. They can get, they can manage very different shaped pools, not even a rectangle. This one shows, kind of a Grecian cap on either end, but does give you an idea of some of the options you're allowed to work with. We'll probably do a separate webinar specifically on incorporating these kind of cover systems into a pool, but they're great to help with keeping the pool warm, protecting it from winter, keeping dirt and debris out of it. And this one, we've got what's called a safety ledge and a safety notch that allows you to actually walk on the cover. You'll get ankle wet when you walk on it because it's somewhat buoyant, but that safety ledge lets you walk out in the pool if you had to. And you can kind of see how this would actually end up closing up when it's done. So into the construction side, we're going to talk through, some of Bill's major construction, and he'll probably carry most of the conversation from here, but this is the start of the overall project, doing the underground equipment room, sleeving through the wall, etc. So talk us through what we're looking at, Bill.
This is the foundational support system for the bunker. You can see on the right, you get pipe sleeves coming through the poured concrete foundation. The soil around it was filled. You can see the organic line probably down 4.5 feet or so. So some of this pool and the hill slope went up. So some of this pool is going to be unfilled. So the ground, we had to get the soil out of there and had to get this bunker set with its foundational support and our sleeves going into it, knowing that that wall that you're looking at is going to have part of the pool sitting on top of. So the soils had to have, we had a geotech analysis, good soil science, make sure nothing's going to move for differential settlement, and then put the other part, the ocean side part of the shallow end of the pool onto this bunker.
Well, and obviously layout and construction of these areas get much different than your basic flat backyard where we get started with, we can use a tape measure and a couple strings and start lining stuff out. You end up working with surveyors, checking grades, checking locations, coastal agencies, and whatever else you need to deal with. So
yeah, we had, there was a whole team, you know, civil engineers and site guys and stuff. We were going to go off of their points. I mean, it's not that we can't do it. It's just, I don't want to do it.
Nope.
And I don't want the responsibility.
Yep. And a lot of times there's not a house you have to work with or something like that either. So a lot of times you don't have much control. So
there was houses up and we were fighting for access. This was, everybody was on a little postage stamp.
Oh yeah.
So here's the, got the stone into the pool for drainage. You can see the lower trough, and we use the burlap bags, these feed bags. We fill them full of stone. We build up our support mechanism for the shotcrete and also for the support for the stone, and kind of lay out the three-dimensional shape of the pool on the exterior earth side. So it's good for us. It's an in-place support. It's an in-place drainage system. And we have a pipe to grade out of this pool that goes down below in case there's any type of moisture getting underneath the pool from the hillside or the driveway coming down. Because as you take a look at the soils, it's clay. It's cohesive. You got some cobble in there, but if it's going to get wet, it's going to expand and give us some thermal pressure. So we try to take that into consideration. You can see the shallow end. So the tar paper, or the paper you see on the right-hand side going up the trough between the steel and the orange caps, that's actually the top of the bunker. So that's actually the top of the concrete.
So that's a protective membrane that's put on top of the waterproofing before we backfill with gravel, so we don't damage the waterproofing. So what you're looking at the right of the screen is the actual underground equipment room that we're now already working on top of.
That's correct. So we have those vertical boards in the right-hand corner of the picture kind of hammered into the concrete on the below. And then our little shelf, our little kitty 6-inch shelf, we're starting to build up. We have our first gauge of steel. We've bagged a rectangle for our cover box, which drops down below the two. You can see the blue level. That's the edge of one side. There you go. So you can see how it drops in there. Now, before we started doing this, take a look at the picture on the middle top. You can see the concrete floor we poured, the block wall system, and now the plywood between the two block walls. That is our grando cover vault. So that's where it's going to come through, and we're just going to use it as a form. It's all right. Well, let's just get this poured, get it surveyed, and then we'll do steel bag. We'll do right up against it. We'll use it as a form, and we'll shoot against the plywood, and the plywood comes out after we finish the shot. But that's kind of a foundation support mechanism that's surveyed, so we know what we're doing in the right spot.
And that'll house all the equipment that lifts the lid and rotates the cover and ties the cover system into the automation.
Here's the starting to do the winterizing. Winter conditions, it's getting cold. You can see the house. So you see where the machine is, the lull on the left-hand side. That is the only access way for concrete trucks and everybody else working on this job, including the masons. So masons think they have every right to be on the job site as we do, and it gets to be somewhat cumbersome. So the general contractor did put up a nice shelter on top, kept it heated. We have propane tanks going. This is the raised spa, starting our plumbing loop. You can see the forming on top is for the exterior perimeter overflow, vanishing edge spa, which will drop down into a gutter system, which is a lower plywood. So that's why it's cantilevered. And then we're starting to set up our toe kicks details and our stone bags. On our first cage, this is to support the elevation and the stone, the drainage from top to bottom. It's a terrific way to hold everything back.
Yeah, and you get with the stone bags and the stone backfill, we basically get 100% compaction just by putting it in place. And once you shoot it in place, you're basically holding the forms for you, and you shoot to it and lock everything into place.
Then it's just drainage stuff.
Yep. Yep. And if you haven't seen, if you haven't done a toe kick drain detail or watched one and seen how it's constructed, we're not going to dive into it on this deep dive. We are about to publish the last deep dive we did with Luke and Amy Denny, where we talked about tile install and complicated spa details. And we do go into depth on how we did the toe kick detail and the glass tile install. And so you can, if you're interested, you can go to our YouTube channel and see that one as well. That'll walk you through those different aspects. We won't spend that much time on them today, but you can kind of see the pre-planning of doing a toe kick drain that's going to be up underneath the benches in this image itself.
Part of the pool, first cage of steel going in, we get the polylock chairs, keeping it off the ground. You can see on the right-hand side how it dips down into the trough. We're starting to get into the layering of steel. All of our return system is going to come up through the back side of that floor underneath the pool, and then we'll get our gutter system. We'll drop out the backside and run around the outside of the pool, attached to it by unistrut or something. But this is starting to get our steel in after the base plumbing is in as our first cage. A lot of steel. I don't put foam blocks in there. I don't take up concrete space with, if we're going to sandbag it or something like that. They're so complicated and so many angles and turns, Rick, that I said, okay, listen, let's just get a bunch of steel in there because we want to control shrinkage.
Right.
You have a volume change with that amount of concrete, that amount of heat. You're going to have plastic shrinkage, autogenous shrinkage. You're going to have all types of volumetric change when it goes from a plastic state to a hardened state. I said, the last thing I want to do is see shrinkage cracking coming through the plaster because I have so much concrete and the volume got smaller because it cured and got hard. So we, not the cure, but the remedy for that is you have to have the right amount of steel.
Right. So basically when we get into large masses of concrete, we got three problems. One is having enough steel so we can manage temperature and shrinkage cracking, because we are going to have some volume change. And what often you'll see happen is people will put steel where it needs to be structurally and leave a massive void below it out of ease. That's problem number one. You cannot do that. ACI specifies and gives you some good guidance on what your steel to concrete ratios need to be, regardless of structural necessity, only to, as part of the shrinkage and temperature problem. So there's a number of steel you need there. The second problem, obviously, with what you see here is there's really no way we can do a proper shotcrete job and get all this consolidated and get all the shotcrete and concrete where we need it. So you'll see in the upcoming images that they pump in and vibrate a huge portion of this section to get it up to the stage where we can come back and actually shoot it in place. We've actually got a project we're in the middle of now that's got some larger masses of concrete that we have to put together a thermal management plan so that we can keep the concrete cool enough during the curing process that doesn't get so hot that it causes other structural problems and major expansion in the curing process before it then shrinks. So there's quite a bit of complication to get into when you start getting to large masses of concrete. And it doesn't take much to get into that kind of need. So,
well, you should, as a pool contractor, if you're a pool owner or a pool contractor or a foreman, you should take a look at that big shelf and say, no way would I ever shoot this.
Yep.
That should be your only thought. Because if you think you're going to get some nozzle and to shoot through all those layers of steel, you're out of your mind. First of all, you don't know what you're talking about. Second, you're out of your mind.
Right. Yeah, you definitely have to, because the engineers might not point that out to you. The engineers me and Bill just walked one of my jobs, and there's places it's a cast job at this point, what we're working on is a tank, but you couldn't even see through the steel for sections 3 to 4 inches in width because of so much overlap in the corners that doesn't show up on paper when it says number 6 is on 5 or 6-inch centers. But as you wrap the corners and do your ties and do your overlaps, you actually start running. You can't even think about shooting it. So always
ACI doesn't say that you can shoot. ACI doesn't take pool concrete into consideration. They take in mock-up panels or straight walls or something. The swimming pool shotcrete and normal shotcrete are sometimes two different animals. And corners and radiuses and elevation changes and steel overlapping and stuff. You have to be able to understand that I can't get concrete around this when I shoot it.
Right.
Here's you're going from here's a part of the rebate. Spas in the upper left-hand corner. You can see the main drains down below. I got a number of cages of steel in there. So this is a rebate that's going to be structural. So I have my stone bags, we're going to shoot against it. And this is because when we started to do this, the first call I made when I got this job, we priced this, I said, okay, Rick, I need to put you on, and we need to figure this out to make sure A, it's going to last, and B, it's got to be right, because this will be the showpiece for everybody doing acrylic panels in the Northeast, especially us, and we have to do it right. So this is the amount of steel that needs to support that panel.
And you can see, I kind of annotated in there so you can see it, but that we're going to create a recess where this panel can slip into it. And then that panel is what's considered a cantilevered panel. The bottom of the panel, the way it's grouted in place, is actually giving us the structural support, the full length. The end connections don't really, we do have a connection that helps, but the reality is the panel is designed just like a retaining wall in a cantilevered situation. And so we designed that rebate and those tolerances as well to make sure it can slip that panel into that rebate. And then we come in and grout it and shim it and caulk it into place. So you can see there's a ton of steel here going on, lots of detailed steel work that needs to be handled really well. So
and don't be, so if someone looks at this and say, oh man, I don't know if I can shoot this. If you're standing at a 90-degree angle shooting, like on the lower left-hand corner, you're facing that vertical wall at a 90-degree angle, you can shoot that. You're standing in the floor, we can pump the floor. We don't have to shoot the floor, but if you're looking down and you can see, there's enough space to get concrete on, you can do it. Or you're looking at that double cage in front of that spa, you're going to shoot that. So yeah, I can shoot that because I can get concrete around there. But it's different when you look at the 3-foot depth of concrete with 4 different cages. I mean, there's number 4 and number 5 bar on this job. We can still shoot around it. When you get tighter and bigger, like you were talking about, number 6, no way.
So did you, like us, when we do our rebates, we usually shoot them solid and then cut them back out. Did you guys do that in this situation? Did you actually shoot it, or did you try to form it out of your way?
No, we shot the floor of it and the uphill side, and then took a 2x10 and then shot the bottom side and the bottom wall into the trough.
Okay.
With shotcrete, there's no expansion joint, there's no cold joint. So we could do that. So I have a monolithic U, but I didn't do it all at the same time because I wanted it, I think you were there.
Yep.
We wanted it flat.
Yep.
We wanted the form board flat, and I didn't want a lot of tolerance in this channel.
Right.
I wanted to make sure it was as conducive a setting for this acrylic panel, because I was a little nervous about it. I just didn't want to shoot and cut it out and say, okay, because we shoot and cut and go, it's rough.
Right.
And we have to go back and grind and chip and like, Jesus, I don't want to do that. Let's just get it right.
So he basically shot the floor, shot the wall up, shot the other floor, let that set. Then we set forms in this void here after the fact. Yeah. And then we could come back in and shoot the balance of the rebate, which is sitting right here. So,
and that's still a 8-10 inch wall going down. So
I mean, lots of concrete there, but again, if you prep it right, you're ready for it, you understand how to do multi-day shoots, you can do that all day long and get a perfect connection, and not have any different than being cast all on the same day. So it certainly works just fine.
Thank you.
You're welcome.
A lot of steel in the stairs. We actually shot these stairs, and then the owner and the architect came back and said, you know what, our stairs are too big. They go into the pool too much. We need to cut off 18 inches. So we had to chip them all out and do them again. Ugh. But that's okay.
Good fun stuff.
Still monolithic.
But again, same steel scenario here, right? We didn't run steel on the perimeter of the stairs only. We have a thickness of concrete here, so we provided enough steel within the entire section of stairs so that we get all the proper steel ratio to concrete, so we don't have shrinkage cracks and temperature problems.
It's funny. So I come from I'm a 3rd generation pool builder, and I can remember as a kid doing these pools, and they would throw in like look like a stepladder for a big birthday cake full of.
Right.
And never put steel in the stairs. Some cracked, some didn't crack. And I always thought to myself, well, Jesus, I don't remember a lot of these issues happening when I was a kid, but I never paid attention to it. I always thought the vertical cracks coming across were normal, natural.
Right.
Well, they're not. And the reason all these things cracked is because we didn't have enough steel on.
Right. Regardless of what the structural might need for the face of the steel.
Yeah.
Right.
So we're casting our large sections. I mean, you can look at the steel and you stand on top of that with a nozzle and you can say, there's no way I'm shooting this.
Yeah, when you're looking in here, you would have so much void and you never have it all covered. So you also see a guy behind the guy with his butt hanging out, and he's got a vibrator. So anytime you place concrete that's not being pneumatically applied, you need to vibrate it in place at all times.
With your butt hanging out.
With your butt hanging out.
Yeah. You got to be a redneck doing this.
I would be careful bending over with a guy that has a vibrator, though, just to be cautious. So But the end result is anytime you place concrete naturally without it being pneumatically applied, there should be a vibrator. I kind of argue with some of our contractors sometimes when we're doing like block walls and house footings and they don't have a vibrator. I'm like, all concrete gets vibrated, whether it's in a form, whether it's going to earth. You consolidate concrete that way properly. And if you've ever ran a vibrator, it would amaze you how quickly you can dissipate concrete into all those voids very quickly. So
it would amaze you how many voids you actually have.
Right. Yeah. It is, once you hit it with a vibrator, that mud just goes in all different directions very quickly. It's once you've done it and understand it, you'll realize why you vibrate all concrete if it's not being pneumatically applied.
So we're going to pump this in where the guy in the blue checkered shirt is holding a hose on the lower elevation. We're not going to pump the concrete to the edge of the steel. He's holding it back. So this is going to be like his last layer, one of his last layers going back and forth. So then we'll shoot the outside and shoot the top. So we will shoot the exterior of this, but the inside volume is going to get cast. So we're doing the same thing here. You can see the steps have concrete in it already. We pumped a lot of those steps. The floor is getting a lot of concrete, and we're just moving back and forth. And then the cover box is getting all shot. When we get to a big pool that has a lot of concrete, we like to do the floor, finish the floor, and lock all the steel in so it's not moving. Then we'll go back and do a vertical element. I do not like to shoot, and we won't shoot walls and then come back and finish the floor if we can avoid it.
Right.
The key is let's get the damn floor shot, keep the rebound out of it. So you can see we got to do some bang off the steel and get all the snot out of the bottom of that cage up against the vanishing edge. But it's if we can get the concrete floor set and locked in, so you've got to bring 2 more shovelers.
Yep.
So what?
Yep. So every time when we can, and not every single personal time, but almost every negative edge pool we now do, we'll shoot the exterior walls of the lower trough, the floor of the lower trough, and up and under the floor, the steel of the negative edge as our first shoot. Sometimes we shoot the whole floor of the pool, and that's ideal. And then we come back so we can actually set forms into the solid concrete and have our wall and steel spacing properly. We can put standoffs on the back of the steel against the rigid forming and get a perfectly nice, clean, straight wall. Then that steel is not bouncing around. The real issue you run into when you're shooting these negative edge walls that are kind of hanging in the air and you got pegboard tied to the back of them, they keep moving, they move a lot. And so you start creating cold joints and voids within that shell through that process. No matter how good your shotcrete crew is, that steel is not rigid enough to not be bouncing around on you. And then you start stripping and pulling off the pegboards while it's still wet and somewhat pliable and plastic. You can do a lot of damage to the wall. I've even seen walls fall down and have to be started back over. So we like to do it this way. It's not the most financially best or easiest way to do it because you'll spend more money. You'll have multi days to do the shoot, but we got a pool coming up. We'll shoot all the floors in the negative edge basin. That crew will leave. That's almost a whole day job anyway. We'll spend the rest of the week getting it all formed up, prepped and ready, pull the rest of our wires, and then we'll come in and shoot the walls of the pool and the negative edge too. So,
but if you think about it, and anybody listening to this or going to listen to this in the future, you're not cutting corners.
No.
And you can't have that. I'm going to save in dry gun. I'm going to save a pallet full of Portland, or I'm going to save some steel on this. I mean, if you have that attitude when you're putting acrylic panels in, you should get into another business,
Correct.
Another career. Get out of the pool business because
Right.
you're not only you're hurting yourself, you're hurting me and hurting you because some jackass is going to screw this up and say, well, listen, all acrylic panels fail or enough. It doesn't work this way because I heard somebody out in California screwed it up.
Right.
I mean, don't ruin my business because you're an idiot.
Well, and anytime we do concrete and we talk about extra expenses of doing a multi-day shoot, the reality is it's not extra expense for me. It's built into the job cost. And so the client pays extra for it. But when we explain to the client why we're more expensive and explain to them the reasoning behind it, I'll tell you, it's a great selling point when they start to realize how much you understand concrete, formwork, shotcrete, and why it's important on probably the most critical wall in the entire pool, the one that's out there floating on itself and having to hold back water. They're usually willing to pay the $2,000 to $5,000 to $10,000 more that the pool might cost to construct to do correctly. So
I had somebody tell me a long time ago, said, concrete's concrete, plumbing, forming. It's in the design and the concept of the job. And I thought to myself, that person's crazy. Anybody can, if you do a lousy pool versus a good pool, you should be able to sell that. You should be able to promote that.
Right. Yeah, without a doubt.
Here's the, so we're getting into the edge system, the perimeter overflow, and we did some carving of this, so we'll get to the floor down here, and we'll shoot the walls on it, and that's his right foot is at the top of the elevation. That's the form.
And the outside of what's going to be the overall overflow gutter, his left foot is sitting on top of what's going to be the negative edge weir that goes into that gutter. And then you can see the grando cover behind him, and the beyond, the pool beyond, obviously.
This is, you want a salad for lunch? I'm looking for a steak and cheese, or ordering lunch here. I have no idea what the hell we're talking about.
No, but we're just on site. I just wanted to show, you can see there's areas we haven't finished shooting this pool yet, and we're obviously going to come back and shoot them later, but there should be no fear to do that if you know what you're doing and you do it correctly and you follow the guidelines. Clean surface, get a good angle of attack, surface saturated damp. No
saturated dry, get all the debris out of there, blow it out. There's no cold joints, there's no time limit. We could leave this where you and I are standing, we could leave it and come back a year later and continue on, there'd still be no cold joints.
Correct.
That's the beauty of shotcrete. So you can see how we shot. So we shot the face of the wall, we shot the top. So these guys are cutting and trimming now after we did the shotcrete. So we have all that cast underneath it, but we have probably a 10 or 12 inch layer thick of shot on top of it to lock it all together.
And you can also see, these are good pictures to look at the overall winterizing system. So we're going to be here a while. The general contractor put something together here, but it's a, nice roof system, fully enclosed, decent lighting system, so we can see what we're doing, heated and conditioned so we can keep it warm enough in there to work, and big enough and out of your way so it's not standing on the shell of the pool. But many projects you get involved in, and we've got the opposite here. We're usually fighting heat and sun, so we're tenting projects just to keep the heat and the sun off of it, and you get in the East Coast and you're dealing with the cold. So obviously part of the cost of a project, and this is a type of project where the client didn't want to wait for the seasons to come back to be back under construction, so he's willing to pay to keep it going and run through the entire winter. Just a cross section gives you a good idea. We've got on the right side of this pool, that's this negative edge, it's got multiple edges or multiple layers that steps down into the lower trough. And so I just had this image I wanted to throw in there so you can see a better view of what the rebate looks at the bottom of the acrylic panel, what the rebate looks like on the side where it gets into the negative edge, and how the trough, even though we have a perimeter trough, it's not all at the same elevation, so it's created a nice system of waterfalls. There's some better images of it coming up, but here you can see what we did with our negative edge, where the acrylic's going to match. So this is our rebate where the acrylic's going to sit into place. So this is where acrylic's going to sit right in here in this space along this wall. So that is a critical piece. This is a critical structural piece. We're doing an expert witness project in Louisiana where they didn't have enough structure here at all. They had about 3 inches of concrete with no steel that was holding back their panel. And so obviously that's failing. So we're reconstructing the pool for them eventually. But you can see where we've got a sloping negative edge that's going to slope away. We're going to create our panel the same detail. Again, one of the conditions that Bill had to explain to his client on this job as well, when the temperature changes, the concrete's not going to change very much at all depending on temperature, right? It'll change some, but very little compared to the acrylic. And so we have to find a nice medium location to set the elevation of our acrylic, because it's going to change. It will not flow perfectly like the rest of the concrete will. There'll be some times where we might get some dry spots on the acrylic panel because it will grow in size, both in length and width, or length and height. And so you have to accommodate that. So we had to find, a decent ambient temperature to set the panel, so we're kind of middle of the road, but realize on a panel of this size, it could change in height as much as a 1/4 inch. Which obviously we can't manage that kind of tolerance. So there's customers has to understand and have the right knowledge of what the end result's going to be, that it will not perform as if it was a chunk of concrete. So there's a lot of information to be provided to the client and to be worked out in the project itself. But you can tell these are big panels. They're taller than the guy standing there.
So the Danny's our guy on the right hand side, and Warren, the black guy, is the tile installer from Bazaza, New York City. Very talented. So, and Warren and I are good friends. So I said, Warren, come out and take a look at this in shotcrete and see what you're going to want. And you and Danny get together and talk about, okay, this is how we're going to approach this. So the key with this whole thing was communication. I think we did a good job with it, because he came out and said, okay, I need this plane, I need this way in order for me to set the tile. So he got an idea of, okay, this is what I'm getting involved with.
Absolutely. And again, early on, we got a tile guy involved. We're still at shotcrete. The other thing to plan for is how much are we going to float the wall, because the acrylic panel needs to line up with the inside of the wall perfectly when it's finished. not when we shoot it. So there's all kinds of dimensions. There's a lot of modeling, a lot of forethought goes into this project to make sure that the end result works out. Obviously, we're going to float and true up the pool before we tile it. We have to design our acrylic panel to be proud of the shotcrete when we finish and set it, so that when we set our tile, those come together at the same plane and don't look like a pile of shit. You can see here, there's a good visual of the overall rebate of the acrylic panel, how it's going to set in this trough. So
we will straighten things up. And our shotcrete is not like Drakeley. It's not perfect. It's not troweled and little broom finish. We're shooting it and we're rough. We are 3/8 stone, 1/2 inch stone, and we get overspray and sometimes we'll come back like this in the upper corner. We'll come back and shave it all down, cut it back. We overshoot and then we cut. We don't undershoot. And that's, right now it's in its rough concrete state. However, once we get it cleaned up and get going on it, it performs the way it's supposed to.
The other thing this edge has is we have a safety ledge. It's hard to see in this image, but I want to make a point of it so you can understand how it works. There is a safety ledge right here. That safety ledge comes in here.
For the cover.
And right for the cover. And you can see a little bit in this space. Let me get to a different draw. The safety ledge looks like this. It's kind of hard to tell in that image, but there's also a recess here. That's where the cover is going to come up out from the floor. When the cover comes up and flips down and starts floating, now we have 3 inches of space here for that safety ledge to sit on. So if you walk out on the cover, it's got its own buoyancy, but at the edges, it will set down on that cover. You can walk out there and not fall into the pool. Right. Again, had to have a conversation with the client. The acrylic panel does not have a safety edge on it. So as we get to the end of the pool in the outside corner, if you were to walk out there, you would probably sink down to your knees. But wanted you to see that when you do these covers, there's again, in this negative edge detail, there's an awful lot going on in this little space. It's not just a simple slope. So all those details and elevations had to be accommodated because we have the same safety ledge on the other side. And then the right picture is just, you can see the what's left of the cast upper portion, or the form that was stripped off of the upper shell of the spa that we shot into. Well, I got to erase this before we move to the next panel, or it'll come back with me.
Reynolds Polymer, the manufacturer. This panel was going to be connected, fused, and it is not. So we had to come up with this mullion setup. So you can see the mullion in the corner as we're setting these panels, but you can see the thickness of the panels and just how beefy they are. So the rebate is appropriate. The rebate support system, you take a look at these things and say, oh man, I better make sure this is not going to move. And I have enough room for the caulk. Because when it does move, it's got to move and not break the seal. And so we wanted to make sure we did this right. So this is what we're taking a look at.
Yeah. So the benefits of acrylic is we can get it just about any thickness that we need it to, and we don't lose any real clarity in the thickness. With natural glass, you start turning green really quickly, and we can't get much more than about 1 inch thick. Acrylic, we can get into 24 inches thick if we want to, and we can still see through it almost like it's not there. These panels, I think, are 6.5 inch thick panels to work together. Obviously, the larger panel dictates the size of the panel. This one probably could have been a little bit thinner, but they're engineered to work together. And the fused corner would have been beautiful, but obviously we decided against it for the protection of the client. You can see the safety ledge a little bit here next to this piece of lumber on the left photo, give you an idea where that cover is going to run along the side, and then just giving you a feel for them setting these. So
we should go back one.
Yep.
So the corner of the panel, the left-hand corner of the panel, is a little notch right there. That was for stainless steel horizontal support to hold the two corners down from moving.
Yep. So right here.
So so the panels are notched, we slide into the rebate, then we have a stainless steel with a couple of dowels that we get into our shotcrete, and this bridges over the top of the notch, and then more in our tile. I had a tile over this to hide it. Yep. And this is for vertical move.
Well, it was actually originally for the rotational movement when it was a fused panel. So part of what we ran into in this job is when it was a fused panel, we would have the panel to the right pushing out, wanting this panel to rotate up. So we had to hold it down. That actually goes away with the mullion connection, but we had already fabricated the panels and already fabricated the rebates to accept it. So we ended up with panels with that condition already.
And it's actually good because of where we are in New England.
Yep.
The more support I can have on those corners, because there's on that inside corner, I could use all the help I can get.
Yep, for sure, for sure. This will give you an idea. This is the outside of this panel, obviously, but they've actually, you can't see as well now because we don't have the stages in between, but they've grouted that panel in place. They've siliconed it, and there's a grout system, there's a sealing system, and then after all the tile and tile work's done, there's usually a beauty caulk as well. This is all the structural caulk that goes in place and sealant to hold the window in place. The other thing you need to make sure when you're doing panels and getting into your details of your overall pool size is the part of the panel that's slid into that notch, the rebate, has to be painted so that you can see right through the panel. So you don't want to look into that caulking and that grout and those shims. So you also have to know before the panel ships your exact finish sizes of what your pool's going to be, so that when you finish tiling to them, it's behind the paint line. If you actually don't do that and you get your grouts and your thin sets and your tile out past the paint line, when you look back from the other direction, you can see behind the seams and see the back of the tile. So there's a lot of nuances to get acrylic to work out and come out as a properly finished product and not look like you made mistakes, and you can easily do that.
That's why you let the manufacturer set.
Yep. And yeah, we also try to work with the right people at setting panels. Don't set or buy acrylic panels without having a team player in this.
Don't do it yourself.
Yeah. Reynolds is a manufacturing company. They do some of the design and engineering. And then this project itself was actually set in place by Aquatic Glazing and Jason Jovag and his team. This is our ugly at this point anyway. This is this massive stainless mullion that had to be retrofitted and engineered after the fact. It's pretty from a distance.
It's beautiful.
It's a beautiful piece of art. So it's 1 inch thick, 316 L stainless. You can imagine the weight, the strength. It's quite the underpinning to this acrylic panel system, especially to do after the fact. And we had to specially design it to work in what we had for concrete. Remember, our concrete at this point was cast. The acrylic panels were already in manufacture and were also cast. And so we had to come up with a structural support system that worked. And so we went through a couple different iterations. This is where we ended up. It worked just fine, but this will give you a better view from the outside, what it looks like. And also the caulking joints. So anytime we bring panels together that aren't fused, this huge caulking joint isn't just because the panels are too short. We've designed the panels to be able to move almost an inch.
Squeeze.
They can squeeze and stretch. And so you have to compensate for that right off the bat and make sure you have room both at the end of each rebate and also the panels as they come together. So lots to do here. Don't run on your own dime and just buy some acrylic off the street. You definitely can get help to get this done right. And the installer is also the ability to cut, polish, trim, make a different size, get it perfect, and clean it up after the fact. So whole lot of things going on when we're playing with acrylic, especially on negative edges, really changes the overall game. And then the temperature and climate changes also affect everything.
No covered lid, which is going to get glass tile on top of it. You can see the cutouts and the absolute squareness. We had to have it for this thing to not only to open up, but to rise up through our channel going up the vertical walls. And it was I wouldn't call it a labor of love, but it's certainly a learning experience.
Yeah, and so you can see in this drawing, guys, this section right here is actually recessed back so that we can get this cover lid to flip up. And the cover is also wider than the actual pool shell because we have that safety ledge. So as the pool cover comes up out of the floor, and then goes left and it goes right, it eventually sits on this safety ledge for us, and then you can walk out of that pool. To the left is where Bill said we had floating steps. You don't see in this image, but those also had to sit below the safety ledge so that the cover can float on the top of them.
Absolutely. Long wall tiles button out. So we got to make sure that the edge system of marrying acrylic to stainless steel to concrete and glass tile is the same angle. That's key. And that's why we had Warren come out and say, look, okay, once we get the panels in, then you set your elevation, then you know how many tiles you're gonna do, then you know our edge is the same, the razor line is the same, but the angle of that drop off had to be the same too.
Had to be the same. And the main reason, as we did the design iterations, we talked about, we needed to make sure that we could keep the water line looking continuous for the owner. So the water had to carry along this whole edge and look the same. If we turned the edge the other way, the water would have been out here for the pool, and then it would have stepped in and went to the acrylic panel. And so that's why we went through all these different iterations early on to come up with a final solution that created the correct edge on the outside and then made all those parts and pieces come together. Actually, go back so you can see too. This is where you can start to see we've got acrylic, or we got the equipment up underneath where we're working. So the equipment's actually underneath us here, and then you can see because of that we've got the stair-stepped system for the negative edge that keeps changing elevation, but creates these nice little waterfalls next to the garden and just captures water and then at least gets it down to our final surge tank. Bill's got lighting in there. You can see those stubbed up next to the wall. Same thing with that. You start getting to critical tolerances anytime you get lights close to walls. If they're not the same distance and the same angle away, the effect on the wall will be dramatically different and obviously noticeable. So you got to be very careful when you call out those awesome details. You got to be really careful how you pull them off. Just a view from the other angle, you can see they're starting to render and prep, and they're getting it smooth and ready for the application of glass tile.
Mm-hmm. Here's a Pizzazzo glass tile. It's a blend that the architect and the owner came up with, and we have it not only the vanishing edge, we have it on the top of the step, and we have it on the slot overflow, and so it's continuous. And come on, it looks good, and it makes a nice transition to the bluestone and some of the grays around the property, which are actually highlighted in the granite wall behind it. So we kind of we blend into each other. We're not stark, and it really makes a nice marriage.
And even in your climate, you're working in the shade, keeping the sun off the glass, keep managing temperature, rain, all those different parts.
Well, this is a manufacturer's tile installer in New York City. Warren's out of the Bronx, and he does all the tile in all the hotels in New York City that's got a Pizzazzo big job. So we got to know him pretty well. And now he's doing a lot of pools through some of the stuff we've done. Some of the other builders have seen what we've done and hired him as well. So, you know, if I'm going to have a problem, I'm going to have a problem with the manufacturer. Our filter system, Pentair with the Clearwater Tech ozone unit for the pool and the spa. Some off-gas tanks. We're using the cartridge systems, so no backwash, closed loop. And we paint all of our pipes, and we're going to put directional control arrows on it and stuff like that. So when the inspector comes down, he knows what's going on. And we also have enough wherewithal to be able to turn that separate hydraulic loop on in the winter and keep the pool running. Here's the stainless steel gutter system holding back the earth, having a slot for the water to drop into, and we fabricated ourselves and bolted to the back of the concrete gutter ourselves and put a nice seal on it, and it seems to work out that's the easy part.
Yep, that's easy. So you actually put natural grass in here on this project, right? Or is it fake?
Oh, I think it's I don't know, it's awfully uniform green.
Okay, so it might be artificial, but
yeah.
You can, there's a number of different details on how to do this edge, and we've done it a number of different ways. If it's a Lautner edge detail, a lot of you have seen this grass edge detail. I think Bobet carries it, and it's shaped like that, and then your grass is going to sit up here. There's a lot of problem with the grass burning on the edge when it's done that way. We've done both similar details to what this is. The benefit of this detail, you've got a sloping flooded coping, but then your gutter comes down, and then you're much lower here. You bring your stainless out and up. Now you've got full depth of soil in this space here, and so your grass can grow across it if you want to use natural gas.
So
it won't burn as much, so it works pretty well. But there's no single ticket that how you solve these problems. There's no reason you have to go with whatever detail you've seen before. You can always be creative and come up with a solution that makes it work based on the project and create a really stellar look and something unique to what you've seen before. Good pictures they're showing here. You can see the safety ledge that's been glass tiled. You can see the notch where the cover is going to come up to get in that safety ledge here. All those details are starting to come together, and you can obviously see a nice clean line when it's finished to get to the finished pool itself. Goodbye. There's a finished edge, and it's got the glass tile. Now you can see that floating cover. So that floating cover is out over the top of the entire pool. You can see where the seam is. Somewhere about the middle of the page is where it comes out from either left or right and goes in both directions. So you get some
nice tolerance too.
Yep.
We're not pumping a lot of water over this edge. It's a nice tolerance, good tile thickness, good tile edge. And the only variation we have with this edge is the acrylic panel as it changes with the temperature.
Right.
Some days we'll have a dry spot on part of the acrylic wall. Some days we won't.
Yep. And
it's based on temperature and sunlight and how it's affecting it. That's just the way it is. And the owner gets it. He totally understands what's going on.
And especially the other cool thing about this type of cover is we can roll it out and still have the edge running if we need to. So
some finished pictures. You can see we highlighted the top step of the pool with the glass tile, and the rest of it is a pebble surface. And some of the killer views. Nice little project.
Nice little project, nice little piece of beach, I'm sure. One thing to remember too on acrylic panels, we point out a lot. At this angle we can see pretty well, but somewhat of a bird's eye view. But sometimes, and just like this one, you don't really see through the panel very well. It appears to be a wall still. If you look at it, what we're seeing above in the very bottom of the panel is just a reflection of the floor, and then the reflection of the water in the distance. So you don't look through it and see the grass from beyond unless you're underwater. The real beautiful view on the acrylic panel is the other direction coming in. So so now you look at it, you see it from the other direction. You can see how awesome the acrylic panel can look from a distance, and an awesome piece of architecture as well. And there's the corner. So a couple things. There's a number of people on this live. We can open up to question and answer, and open up to you can either text or talk, and you can also see that we've got our emails and our phone numbers up on the right if you want to ever reach out to one of us and talk about it.
That final picture where the trough is.
Yep.
That's a fiberglass grade system.
Oh, okay, yeah.
Because the client he had some grandkids, so he said, "I don't want it so deep. What do we do?" I said, "Well, I'll put a fiberglass grading system in there."
Yep. So just set it just below grade, just below the water, keeps it safe so you can get
I think it's
ankle deep.
18 inches down.
Okay. So yeah, another easy detail to close up a huge. Sometimes when you do the proper volumes for this size pool, that basin gets pretty deep, and so it's a little bit unsafe. So that's an easy solution to the edge of that. So I appreciate Mr. Bill Drakeley coming into Arizona and spending some time with me, and putting together a joint Watershape University and Ask the Masters podcast of complicated pool structures and how to really put them together.